questions that I'll start out with. Just the easier way to do this is maybe go one by one. We can just kind of rotate down the line, or perhaps if someone has something that they would like to interject, maybe raise your hand. That might be an easier way to do this. And so my first question, I think it's fair to say, based on my own experience, based on the lively discussion in the chat, that there is a lot of hesitancy, or the data is not super clear on claims of sequestration on mass timber. A lot of that is sourcing. A lot of that is end of life, circularity. Kind of all of these issues are really, I think, dovetailing. And so the question for me is that the mass timber offers a lot of other benefits, right? There's the green jobs, the mitigating wildfires, decarbonized buildings potentially, but it's cleaner construction sites, faster construction sites, the biophilia. Where do you kind of fall in this realm? And what do you think, or what do you see the industry needs to really kind of better LCAs, obviously, but to really kind of hammer home some of these kind of questions? Erica, I think you had the most relevant portion on this. Do you mind going first?
Hi, everyone. Could you rephrase the question?
Yeah, so I think that there's a lot of question about the data. So, LCAs, carbon sequestration, embodied carbon around mass timber. Where do you see the need to kind of, I guess, answer some of those questions, or do you feel that those questions are answered and it's more an issue of sourcing and end of life selection or decision?
Yeah, I don't think I'm an expert on this, but I do feel like there's some information, and there are platforms that provide useful tools for calculating life cycle, the life cycle of a building and the various different designs that building might take on. But there's so many assumptions embedded in those platforms, and I think not all of the assumptions are well understood. And so that's one of the challenges that I have come to experience. I mean, even in the study that Corey shared for the project in San Francisco, they were looking at comparing European sourced mass timber with North American sourced mass timber, and the fuel assumptions for cargo or for shipping are important, right? Like, what is the fuel used in the ocean freight? And that's something that is not that I don't have necessarily visibility to as someone who's just reading a report. Usually they don't go into that kind of detail. So that's been frustrating for me. I think the other challenge with mass timber is that we're relying on environmental product declarations from manufacturers to kind of look at, I think the term is, I think it's cradle to grave. I think it's, what is it? What's the boundary? It's really from manufacturing until the product arrives at the building. That's the system boundary. And then we're looking to forest management certification systems, FSC, SFI, PEFC, to consider kind of further upstream, like carbon and sustainability implications and questions. And there isn't an easy way to marry the two. And I think there's just that part of the puzzle feels less understood. The manufacturing feels more understood. The forest management feels less understood. And there's a lot of opinions and a lot of strong feelings about it. And just because someone isn't FSC certified doesn't mean they're doing wrong by the environment. And so I think there's just a lot to learn there and questions to ask. And so hopefully that's a little bit helpful.
Yeah, Guido, do you have any thoughts on this?
No, it works. For whatever reason, I couldn't unmute. So I think to clarify one myth, building with wood is not carbon neutral. So theoretically, if you assume a tree grows in the forest, captures a bunch of, or filters CO2 out of the environment, out of the air, and builds carbon in its structure, eventually that tree will fall over and will rot and release the carbon again. If we prevent that by cutting the tree, taking it out, and build something with it, I mean, first off, we have to realize that only somewhere, depends on the industry, between 10 and 20% of the biomass of that tree is actually used for construction. The rest ends up as pulp, as fuel, or directly in the forest to rot. And then across North America, we still have our slash piles or burn piles. So that's not really that environmentally friendly either, a thing Europeans have never seen or heard about. But bottom line, the idea of this construction is to have a lower carbon impact than other comparable materials.
Right.
And that's still fair to say that we can do that with woods, even though we're far from an ideal product in that sense. And even if we would be much more efficient in using the fiber, we still have other fuels to be used to get into the forest, cut the tree, get it out, process the wood, etc. So those are certainly additions on the carbon bill as well. With mass timber, it's all about basically creating an alternative to concrete. And even in a not so sustainable forest management, the balance for the carbon balance for wood is still more positive than for concrete. And that's basically what the idea is based on, that we want to sequester carbon and store it for a certain amount of time in our buildings. One day in 100, 200, 400 years, at some point, the carbon will be released, but at least right now, where carbon saturation in our atmosphere is so critical, we can at least store it for now, for a few decades or maybe millennia or something.
Do you have any thoughts to add, Daniel?
I'll leave the carbon conversation, I think, to other people that are much more knowledgeable than I am about it. But I do want to make one point about industrialized building systems and the industrialization of construction. And in our research, we find that if we think about industrializing the process, whether that is timber, whether that is timber concrete hybrid, whether that is other eco-based materials, we have a lot of opportunities to improve the resource efficiency of our materials through prefabrication and through industrialization. We had a paper we identified about 17 different ways that opportunities, not saying that they're all true and happening in every project, but opportunities, including the idea that you can optimize optimize new types of bio-based or novel materials and ensure their quality in a higher way. That, usually we use concrete because it's quite flexible, and we might be concerned about the performance of other materials that are performed on site. The other point I want to make, which I didn't have time in my presentation, is that if we think about circular economy, so the idea of cradle to cradle, or the idea that our parts can be reused or remanufactured and recycled in the worst case, we can think about how a design of an industrialized system could be far superior in terms of design for disassembly and creating more thinking around life cycle performance. So while I can't specifically comment on the kind of one-off application of LCA, I think it's because it's not an easy question. It all depends on where you draw that system boundary. And my argument would be, let's be more creative about our system boundaries and be more regenerative in our system boundaries, so that we have these cycles of materials.
And then Corey, I think you bring an interesting perspective as well, being in the Northwest, having direct relations to logging. You're kind of, I think, maybe a little 1 foot in each of these realms. Do you want to chime in? You're muted.
For me, when I hear, this stuff is so amazing, all of the research, and I'm so grateful that people are working hard to further this thinking. And when I hear Daniel's presentation, and I've seen parts of it before, I just keep saying to myself, like, how can I get a hold of those systems and use them? Like, to me, that's the deal. It's like, how do we bridge that gap And working with Scott and the fabric system has been interesting because it's a foot in that door of trying it a slightly different way, maybe of kind of getting at the same end goal, probably, with a few specific goals along the way that are very much about being in California and all of that he's trying to address. But it's like, how do we do it? How do we make these things ubiquitous, and how do we make this happen? Because I think we all agree that you're all absolutely right. It needs to happen and can happen, and it's the way to do it. So how do we do it? And that's just my question always. How can we do this? It just seems so slow. It's painfully slow to me, how long this is taking us to realize climate change is real. Make design ubiquitous. Design, the quality of design, the bar is raising constantly, and it's amazing, right? It's like it's changed so much just from between when I began my career and now. It's unbelievable. I mean, even just in Portland, the level of design and consideration for everything has, I don't know, it's gone up tenfold since the early 1990s, and it's great to see. So maybe it is happening, and I just need to be more patient. But how do we do it?
I definitely hear you on the urgency portion. As someone who's been trying to work on these for over a decade now, it definitely, things are starting to pick up in the U.S., but it has felt much slower. I want to talk a little bit more about this idea of resource efficiency. Erica showed a slide, and on her slide, she was referencing the cubic feet per square foot. And there are direct implications to this, right? There's cost implications. So if you're using a lot of fiber per square foot, cost goes up. You're using more wood. If wood isn't doing any sequestration whatsoever, that's problematic. And so the value-added wood industry is really intriguing to me. It's still in its infancy here in the U.S. In Europe, it's very much component-based, systems-based. Lignotrend, Lignator. There's a bunch of other products, Kielsteg, which use much less fiber, but get comparable spans and things of that nature. Do you see the U.S. moving in this direction? And I'll start with Erica, because you look like you want to talk.
Sure. I think this is a really important question, and the goal is always to be the best steward of the natural resource and use as little of it as is needed in the project, right? And that's helpful in making the project viable from a cost perspective, but it also is prudent that we are just, conservative and thoughtful with all resources, which may be renewable, but are still, trees take time to grow. So I think the challenge that I've noticed or observed in the United States is that the lumber market is motivated by single-family construction, or the lumber industry is motivated by single-family construction. So to put it in perspective, 2% of all softwood lumber that was used in North America, I forget it was North America or the United States this year, went to mass timber construction. 2%, right? So sawmills are making 2x dimensional lumber because that's what's needed to build a stud wall and a single family home, and that's the prevailing market. And I think until mass timber becomes a bigger piece of the pie, sawmills aren't incentivized to figure out how to make a 1x6 cost effectively, which would allow us to optimize CLT layups and glulam layups. Sawmills are not stress rating their lumber. And if everyone stress rated their lumber, we would be able to use less wood in our buildings. They're probably way stronger than we think, than we're giving them credit for, because of the visual grading that we're relying on for lumber. And so there's lots of opportunity, but it's going to take a market shift to incentivize the industry to start to orient themselves toward prefabrication and toward mass timber, I mean, that's, I think, a big difference between Europe and the United States from what I am seeing. And so I think there's totally potential, but the landscape isn't, it's not in the where it would need to be right now.
My hope is that with programs like the Build Back Better, right, we can kind of parallel the new European Bauhaus and the European Green Deal, and start to incentivize, invest in a lot of these programs. Guido, you and
I
I
mean, even just real quick, like even the kiln drying, the lump, like even to make a lamb stock, like is a higher level of processing of lumber that sawmills just aren't set. Many sawmills aren't set up to do, you know, and that that like high level of plane surface, that like very highly planed surface is essential to create a good bond, you know, in an engineered wood product. And there are just so few mills that are producing lamb stock right now, and they're doing it because they're mills that are committed to quality, not volume, and that's their business model, but they're few and far between. And so there's just a yeah, I think that's just another example of the kind of industry landscape right now.
Guido, I'd be interested in your thoughts on this as well. You and I have talked about Kielsteg and some of the other products and some of your other, after some of your other presentations. And I think we have a similar view on CLT, which is just, it's very heavily used, I think, or thought of in the US environment, but not necessarily so in Europe. Do you mind chiming in?
Yeah, and as you said, we already discussed that in the past. It's fascinating to see how much emphasis or what kind of a hype occurred over time, mainly, well, in the US and Canada as well, with CLT. CLT is a very capable product in many different ways, but it's only one out of many. And many times less mass or less wood fiber use can be actually much more efficient. So you mentioned just Kielsteg or other products, which are structurally speaking extremely capable, but using far less fiber. So yeah, it was always fascinating to see for me, you know, what kind of hype was triggered with CLT across North America. I'm not against CLT, but I think we use it a bit too often in applications where other products with less fiber usage would be at least as capable.
Corey, have you guys explored over at Hacker, utilization of other products other than, CLT or DLT? So you talked about mass plywood panels.
Yeah, totally. There's a mass plywood plant here, Ferris Lumber. Has everybody heard of them? And they're here in Portland, so that's excellent. Mass plywood I like the idea of it a lot, and we built our stair in our office out of CNC'd mass plywood just so that we could see the lambs, kind of going down the treads and risers. It's beautiful and structurally super high performing and tested really well and all of that. But the one problem with it right now is this aesthetics, because for all intents and purposes, the veneer that you see on the face layer is just as like a structural plywood, And so even if they do have the ability to add finish veneers to it, but even then it's still just a plywood, like a flat sawn veneer. It doesn't have any vertical grain to it at all. And that just looks so different from the texture of wood grain that you get in wood decking and CLT and stuff like that. So for us, it's been just always kind of this question of aesthetics with that. And I know that's not what you want to hear, but that's, a big part of the realm that we work in is just being really selective aesthetically about things. And so that's been interesting just to have that conversation. We have a building in the works right now that's all mass plywood. And it's saving a significant amount of cost on the frame. I mean, it's a legitimate improvement. So.
All right, we have a question from Bronwyn Berry. How can educators and education institutions, as well as organizations like the Passive House Network, accelerate the transformations you've identified as necessary Daniel, let's start with you.
Sure thing. I think the number one thing is that designers need to go to factories or to production sites or also construction sites. I know that this happens in good design schools, but I think we need more of it. And I think that architects and structural engineers need to see what fabrication in an industrialized and offsite manner looks like, because this will help them have confidence in designing such systems and also understand a lot of the challenges that will come with these types of systems. But this is difficult because they may have professors that don't understand where to take them or what to do. And so I would say that many of you in the audience could reach out to the schools that you've been educated in and suggest different places that they can go. That they can go to a timber lab or a Swinnerton project and see how they're thinking about this. For me, this would be, I think, the first easiest. It's kind of like the small win or the easy step forward that should definitely be happening. And then bigger picture, I do think we need more of these interdisciplinary programs, like Guido presented. That's bringing together, for example, forestry and product design and materials engineering, materials science, and computational design, right? A whole pipeline from start to finish, where people understand that and then specialize in one of those areas. Most projects, most educations are specialized by a specific type, architecture, structural engineering, and we also then attest and assign our professional licenses based off of that. But very seldom do we allow people to specialize in a specific material, with some exceptions that should be noted.
And Guido, I think you have a pretty interesting perspective on where you are. In addition to the school, the university, are you guys doing like tradesperson programs? Do you feel like that's more of an overarching CANFI or PHI issue? Are you speaking with jurisdictions as well, or are you only focusing on the education of future employees or workers?
For now, we only focus on the education of engineers. We try to venture out a little bit more, going to the trade school, have carpentry programs, etc. involved, because I thought creating some synergies is a good thing. But we also had to learn very quickly that it is difficult to have any kind of accredited programs changing, because you have to go through a very elaborate process to add something to a red seal carpentry program or those kind of things. So we encountered pretty quickly that there are limitations in terms of how we can take it as a university. But we do have an ongoing collaboration with the architectural school at UBC. So at least engineers and architects have a little bit something to do together, and also with BCIT, that's the British Columbia Institute of Technology. It's basically a college kind of type educational institution. So we try to collaborate, but there are limitations how far you can actually take it.
And Erica, we received a question earlier today about projects on the East Coast. I think you guys have worked on a couple. I know there's a bunch in Dallas, Charlotte, Washington, D.C. just opened a mass timber library. Toronto seems to be an upcoming hotbed as well. Can you talk a little bit more about what you guys are seeing kind of in the outside of the West Coast?
Sure. We're excited to see mass timber growing in popularity across the United States. We just helped deliver the 19-story Ascent project in Milwaukee, Wisconsin, which is a residential mass timber building currently under construction. We're building a student success center right now at the University of Southern Maine in Portland, some office buildings in Charlotte, North Carolina, and we're seeing mass timber interest in those, in cities like Atlanta and Charlotte and Raleigh and Philadelphia. New York City just adopted the use of CLT in their new building code. I think it's a 2015 IBC that they adopted, and it now allows for the use of CLT in buildings, which is really exciting. And so I think we'll start to see more and more mass timber buildings on the East Coast. There's just so much more manufacturing capacity in the Pacific Northwest right now than there is in the Northeast or on the East Coast. And we're starting to see new manufacturers or just manufacturing capacity grow in the Southeast, Arkansas, Alabama. There are some other glulam manufacturers down there. And I know that there are folks who have been trying for a long time to get manufacturing in Maine. Of course, we have our Canadian friends helping us out for the time being, Nordic and Element 5. So I think, it's just a matter of building capacity, building awareness. There's just so many different fronts that, move forward together in order to make these projects happen. It's, education of the design community, education of building departments, building manufacturing capacity, having completed projects that developers can go walk in and say, oh my God, I want this. Owners, all sorts of clients. So I think it's happening. And what's really exciting to me is that mass timber could be a regional building material, and that one day when the supply chain is robust enough, you could imagine that, you're always using the wood from, within, call it a 500-mile radius to build the buildings in that area, and that people start to recognize, Douglas fir and southern yellow pine and who knows, maybe ponderosa pine and spruce and blacks, there's so much to be excited about that, building our connection with nature. And we're just not doing that with concrete and steel. And so to build regionally grown structures is a really exciting opportunity.
I think that also gets back a little bit to Daniel's presentation on in situ or mobile factories, built or trucked over to site and things kind of fabricated there. We have a couple minutes. Are there any more questions from the audience before we sign off? Alternatively, open it up to the panelists. If anybody has a question for anybody else, feel free to ask away.
I'd really love to understand more about how we implement the industrialization that Daniel's talking about too. I know Corey asked about it. And I think one of the challenges that I've noticed is just with schedules, like construction schedules shift, quickly, and for months, you think you're delivering in October and then all of a sudden it's March the following year. And so I wonder how industrialized kind of offsite fabrication can can kind of be nimble in just dealing with those shifting schedules. And if we have to also build like additional storage capacity, because all these projects will require something a little bit different. If everything were the same, like you could just keep pumping out, and if it didn't go to this project, it would go to the other one. But since there's so much unique, so much customization, I just wonder how we kind of manage the schedules. That's one question that I have.
Yeah, I can give a few thoughts there. I really like the car analogy, and I use it in my project, and you hear the car analogy a lot, but I think the car analogy has its limitations, and we should be very aware of that when you look at platforms in the car industry, they typically have a very clear chassis, and then there's some parameterized changes, but it's not changing the primary chassis, which can be built over and over again. Whereas a building, you are parameterizing and actually changing the structural system. So there's a lot of complexity that occurs there. And so I think first we just have to acknowledge that a building is not a car, and that we have to in some ways be thoughtful about not over industrializing in some ways. Then the second point, I think, kind of directly to your question, we're working now, and I think this is very far away, so I don't expect it's coming anytime soon, on a cloud manufacturing framework or platform. And cloud manufacturing is the idea that you could create a network of suppliers who could provide real-time feedback on their delivery capabilities. And then you could connect that with design. And there are specific ways that we're trying to do it, but I don't want to get into too much details. And you could find specific ways to then, in the design phase, search for suppliers that could deliver, and then have kind of a real-time generation of when would they be able to deliver that. To do that, you need to do a couple of things. You need to have to develop a robust manufacturing analysis system. You'd have to use something in manufacturing called feature-based manufacturing, where you actually look at the way that features are, like notches and holes, are modeled, and we would need CAD systems that could think about features and then therefore translate directly into machine code. There's a lot of work that would need to be done there, but that's one potential pathway forward. And it kind of speaks to, I also saw the question about how do we industrialize without consolidating supply chains, because we do see the risk that we then, the only answer is to then vertically integrate, which I don't think is the long-term solution. I think it's been a necessary step that a lot of modular builders and other industrialized builders have gone towards vertical integration, because they're trying to get this design to production pipeline. But I do think that then you're very susceptible to the shock waves of the industry, and there's a reason why we have a fragmented industry. We shouldn't ignore that. But what we do see is this orchestrator model emerging, where companies are becoming kind of the digital systems integrator or the orchestrator of the prefabricated parts. It's kind of different than a general contractor role, because they're not kind of bidding projects. What they're doing is they're creating a tight network of 3 to 4 suppliers, and maybe they're swapping with these suppliers, but they're kind of negotiating prices and finding kind of more specific pricing points with agreements for long-term partnerships in the supply chain. And this could be one model that kind of leverages the idea of Industry 4.0, where you don't have one company building everything. You have flexible, robust supply chains, but while still having someone in that central role of coordinating the tolerances, the fabrication. Kind of the idea of what Toyota or Ford does is they're the integrator, but they have a network of suppliers that they work with. And so I think this is one potential model that we could see emerge. And we actually, you look at the startups like Juno or Neighbor, they're all going this way. They're going away from vertical integration. So,
right. Thanks for that. That's really helpful. And then I think the follow-up question is just the timeliness of commitments. So the financial commitment needs to be made in a timely fashion so that the manufacturer can procure materials needed for the the prefabricated elements, and plan for it right in their schedule and have time for that. So when do you see that decision needing to be made in this kind of ideal industrialized world, given also the necessity to consider the fact that lumber is a commodity whose price fluctuates regularly, and there's risk associated with that.
And can you keep this brief? So we have a hard stop for a couple of guests.
Sorry, I'll give a provocative answer on the extreme level. So Bukluk, the company I mentioned, they have a supplier in Estonia. They have a 3-year purchase agreement for space in their factory. So they say, we will provide the demand for the next 3 years. If we don't provide the units, we will pay a penalty. And so they've created a long-term partnership because they want that manufacturing time on that factory floor. That's the kind of agreements you need to create continuity.
Wow, interesting. Thank you.
And on that, we will conclude our Q&A. This has been a terrific discussion today. Daniel, Guido, Corey, Erica, thank you so much for your time, for your incredible presentations, and helping advance the discourse on these. Tomorrow, we will be talking about decarbonized building materials, building products, with some past case studies, and a little bit more about fabrication as well. We hope you will join us. Thank you for attending. Depending on your time zone, have a pleasant day, evening, or tomorrow. Ciao, ciao.